Hello class, welcome back to the fourth video of water chemistry and sewage water treatment. Today we will be covering three treatment processes like ion exchange process, reverse osmosis and also disinfection methods. I hope you'll enjoy the session. Now let's move on to the class. The syllabus, as I said, has been divided into 8 parts, and today we will be seeing mainly water softening methods, ion exchange process, principle, procedure and advantages, reverse osmosis principle, procedure and advantages, municipal water treatment, in brief, disinfection methods, chlorination, ozonation and UV irradiation. And here we are moving on to water part 4. Before we move on, please be very clear about the portion that we are going to cover: ion exchange process, reverse osmosis and disinfection, including treatment with chlorine, ozone and UV radiation. Well, there is also another very simple method, that is using activated charcoal. We can remove the coloring matter and other harmful organic compounds present in water through the phenomenon of adsorption. That is the principle behind. Now let's move on. Well, the first method involves deionization of water. This is achieved through the process called the ion exchange process. The purpose of this process is to remove hardness. We have already seen what is hardness, what are the consequences of hardness. So here is a method for the removal of hardness. And for this reason, it is also called the softening of water. A method for softening of water. The syllabus includes principle, procedure and advantage. Well, to know more about ion exchange resins, they can be divided into two on the basis of occurrence or source. One is naturally occurring inorganic resin, for example, zeolite. Please have a look. And the second one is synthetic organic resins. One is naturally occurring and inorganic, and the other is synthetic organic resins. These are more common in use, and the synthetic resins will be seen more in detail in the coming slides also. Well, synthetic ion exchange resins are solid, insoluble, porous, cross-linked polymers. We already know that they are organic in nature, so they are cross-linked polymers which are solid and insoluble, and they have both this porous structure. And the most important characteristic is that they are capable of, I have given it in blue color, they are capable of exchanging the ions present in their functional group. They have exchangeable ions. That is why they are called ion exchange resins. Now, depending on the nature of the exchangeable ion, we can further divide them or classify them into two. See here, cation exchange resin and anion exchange resin. Well, a cation, let's have a look at the cation exchange resin. It is represented by R minus H plus, where H plus is the cation, exchangeable cation. Cation means positive ion. And R minus is the organic part or the polymer part. Then if cation exchange resin is R minus H plus, what would be anion exchange resin? Definitely it will be R plus OH minus, where OH minus is the anion which is exchangeable. A typical example for an exchange resin is a copolymer of styrene and divinyl benzene. We will see the structure of that in the coming slide. Now, it's here. This is styrene and this is a structure of divinyl benzene. Now, when these two copolymerize, they form a cross-linked organic polymer, that is a synthetic resin. Principle behind ion exchange process. When hard water is passed through ion exchange resin, the positive as well as negative ions that cause hardness of water are exchanged reversibly with what? With the H plus and OH minus ions present in the resin, and thus resulting in deionized water. What does that mean? Well, we know that hardness of water is caused by dissolved metal salts. Let us take an example. The hard water sample here contains magnesium chloride as the hardness producing salt. That means it has Mg2 plus ions and Cl minus in it. Well, now let us pass this water through the cation exchange resin. Here, cation exchange resin is R minus H plus, and when the water that contains the cation Mg2 plus is passed through the resin, all the Mg2 plus will be taken away by the resin, and in exchange it will be releasing H plus to the water. Look at this equation. R minus H plus Mg2 plus giving R2Mg plus 2H plus. In a similar process, if the same water is now passed through an anion exchange resin, what is left in the water? Cl minus. All the Cl minus will be taken by the anion exchange resin, and in exchange it will be releasing OH minus to the water. So the water will be losing magnesium 2 plus and Cl minus, and it will be getting H plus and OH minus. H plus and OH minus are nothing but ions of water. So it will not have any foreign ions. So we call it deionized water. And please remember, this process is a reversible process. Well, here is a picture of a mixed bed and exchanger. We have the cation exchange resin bed first and then the anion exchange bed. Water is first to pass through the cation exchanger and then through the anion exchanger. The cations as well as the anions are removed and we get the deionized water, which will be collected from the bottom of the bed. Here I have just consolidated the equations. It is nothing but a repetition. Well, at the cation exchange case, we have considered here two examples. How magnesium ions are removed and how calcium ions are removed. They are similar to each other. Similarly, under anion exchange resin, I have considered two equations, how chloride ions are exchanged for OH minus and how sulfate ions are exchanged for OH minus ions. That's it. Well, here is a question. Why cation exchanger first? You must have already noticed that while using the mixed bed and exchanger, we pass the water sample through cation exchanger first and then the anion exchanger. Why this specific order? This is because if we do the reverse, that is, if the hard water is passed through the anion exchanger first, then the anions present in the hard water, like chloride ions or sulfate ions, will be replaced by OH minus ions. And at this stage, the water will be having OH minus and the hardness causing cations like magnesium or calcium. Then what happens? Both of them will react together, forming calcium hydroxide or magnesium hydroxide, which are insoluble in water. That is, they will form precipitates causing clogging of the equipment, and that will damage the ion exchanger. And that is the reason. And here is one K2 question on the same. In the deionization process, what is first passed through the cation exchanger and then through the anion exchanger? Why? Okay. Well, please note that through this water treatment method, even though it is very effective, we may not be able to remove particulate matter or organic chemicals like pathogens, etc. But the advantages are many. What are they? Let's have a look. The water gets free from all interfering ions, acidity, alkalinity, etc. Well, because of the same reason, we call it demineralized water or deionized water. It is as pure as distilled water. And the deionized water thus obtained can be used in storage battery because the conductivity will be very low. And the hardness can be removed up to a very low level of 2 ppm. And there will not be any sludge formation during this process. And above all, once the ion exchanges get exhausted after use, they can be regenerated in this process because the reactions are reversible here. How do we regenerate the ion exchange resins? Well, let us first have a look at the regeneration of cation exchanger. Cation exchanger, we know it is R minus H plus. It has enough H plus ions in it. When we are using it for treating hard water, All the H plus it has will be replaced by the hardness causing metal ions present in the water. This goes on and it reaches at some point all the H plus will be given to the water. It doesn't have any more H plus to give to the water. That means it is exhausted. So we have to regenerate it. How do we regenerate it? By supplying H plus to it. And what can supply H plus to it? Dilute acids. That is it. So we treat it with dilute acids like dilute sulfuric acid or dilute H2SO4, and this reaction happens, which is just the reverse of the reaction we have seen earlier. In a similar manner, anion exchanger can also be regenerated. For here, anion exchanger needs OH minus ions. What can supply? Dilute alkali. Similar reaction, dilute NaOH is usually used, and RCl minus plus OH minus giving ROH minus plus Cl minus. So this is the reaction involved in regeneration. Here is the actual picture that shows a deionization as well as a regeneration. See the cation exchanger here. Inlet water is going in and coming out through the anion exchanger, and you get the deionized water. Instead, what we do while regeneration, we stop the inlet flow and then we treat when we pass acid through the generator so that it can be regenerated. Similarly, once anion exchanger gets exhausted, we stop the inlet of water and then we treat it with base generator, that is alkali, dilute alkali, and that is how we regenerate it. Here are a few K2 questions. Discuss the ion exchange process of softening of water. We have learned that now. What are ion exchange resins? Give examples. We know that. Then in the deionization process, water is first passed through the cation exchange and then through the anion exchanger. Why? We know that also. How are the resins regenerated in an ion exchange process? That also we have seen. Now to the second water treatment process, that is reverse osmosis, and this is for removal of salinity present in brackish water. And removal of salinity is called a desalination. What is brackish water? That we will be seeing soon. And the syllabus covers principle, process, and advantages. Moving on to what is brackish water. Well, we know fresh water, we also know sea water. And brackish water is somewhere in between. Brackish water has more salinity than fresh water, but not as much as sea water. Usually, the salinity of brackish water will be somewhere between 1000 to 30,000 ppm. Okay. Yes, principle of reverse osmosis. In order to understand reverse osmosis, we must first know what osmosis is. You have learned it in your school classes, but still we will just try to brush up your memory. Yes, you have two solutions of different concentrations, and we are separating them with a semi-permeable membrane. Remember, what is a semi-permeable membrane? A membrane with a very small pores of the levels of microns or even less. Now then what happens? The solvent molecules will flow from the lower concentration to the higher concentration. Please note that each word. It is the solvent molecules which are moving, not the solute molecules. And they move from the lower concentration to the higher concentration. And this process is called osmosis. And this flow happens with a particular pressure called the osmotic pressure. Now let's come to what is reverse osmosis. Well, this is the case. Now we are going to apply a pressure in excess of the osmotic pressure. That is, a pressure greater than osmotic pressure is applied on the higher concentration side, and let's see what happens. If we apply a hydrostatic pressure in excess of the osmotic pressure on the higher concentration side, then the flow will reverse. The solvent molecules will reverse its direction. That is, they will move from higher concentration to the lower concentration side. And this is nothing but reverse osmosis. Now let us see the process in detail. Let us take seawater and fresh water and separate them with a semi-permeable membrane. It's usually made of cellulose acetate or polysulfone, etc. Here is the picture, the salt water and the fresh water separated by a membrane. And yes, we are applying a pressure in excess of the osmotic pressure on the salt water, higher concentration side. The pressure will be usually 20 to 40 bar atmospheric pressure. Well, then what happens? The reverse osmosis. The solvent molecules will move from the salt water side to the freshwater side. What does that mean? All the pure water, solvent molecules in seawater is the pure water. All the pure water from the seawater or the salt water will be now moving towards the freshwater side. We are collecting the pure water on the freshwater side. After some time, you can see that the freshwater level is moving up and the seawater level is moving down because we are separating the pure water and collecting it on the freshwater side. So that is how we desalinate or the salt water. We have a colored picture here showing the same thing. You can see it here. Okay, let us now move on. Advantages of reverse osmosis. Well, it's a simple procedure with high reliability. It's called a superfiltration process as it removes ionic, non-ionic, colloidal and also organic matter of very high molecular weight. See, certain colloids like silica colloids are not even removed by demineralization process. It can be removed through reverse osmosis. Well, coming to the semi-permeable membrane, usually it has got a very high lifetime and the replacement of the membrane, it is done in 2 years or so. The replacement is the only maintenance that is required in this process, and the replacement of the membrane is very easy, and also this is considered, reverse osmosis is considered economical when no other source of pure water is available. Well, on to a few K2 questions. What is brackish water? What is desalination process? With the help of a neat diagram, outline the reverse osmosis process. Many times this has been asked. Mention the advantages of reverse osmosis. I'm sure you're all confident in answering all these questions. Now let us move on to the next topic. Now we are at municipal water treatment, the next stage. What is municipal water treatment? It's familiar to us. We are talking about the domestic water or the drinking water. We all know that we get the drinking water from the huge water bodies around on the earth. But we cannot use it as such. We have to treat them so that it is transferred to the drinkable form. The drinking water should be odorless, colorless, with an acceptable taste and with no suspended impurities and less turbidity, and also slightly alkaline pH of around 8. And most importantly, it should not have any disease-causing microorganisms. So all these have to be ensured by treating the water, and the process is called a municipal water treatment. Mainly, it has got 2 stages. One is the removal of suspended impurities, and the second one is the removal of microorganisms present in them. Well, let us consider the removal of the suspended impurities. This has 4 stages. The first stage is screening. That means we are passing the water through large filters with relatively huge pores so that the large floating impurities will be removed, screened from the water. And once it is done, the screened water is aerated. How do we do that? By bubbling water through it. And why do we do that? In order to remove objectionable dissolved gases like volatile organic compounds or carbon dioxide or hydrogen sulfide or other metal oxides. Now at the third stage, after screening and aeration, the water is allowed to stand in huge tanks. Why? In order for the colloidal or the suspended particle to settle down under gravity. Sometimes in order to enhance the process, we add certain chemicals like coagulants. For example, alum, potassium sulfate, aluminum sulfate, 24H2O. And then once all the colloidal particles are settled down, what do? We collect the supernatant liquid, that is the clear liquid above, and it is then sent through fine sand bath for filtration. That is the fourth stage. The first is screening, then aeration, then sedimentation, and the fourth one is filtration. We send water through the fine sand bed so that the rest of the colloids, if any, will be removed, and also to some extent microbes and even bacteria will be removed. Well, this water is finally sent for removal of microbes or disinfection process. How do we do that? By chlorination or UV radiation or ozonation. We will be dealing with that in the coming slide. Under disinfection, we will be covering disinfection through chlorination, ozonation, and UV irradiation. Under chlorination alone, treating with chlorine, chloramine, bleaching powder, and also breakpoint chlorination. What is disinfection? It is the selective destruction of the pathogenic microorganisms from water using suitable disinfectants. What are pathogenic microorganisms? Disease-causing microbes like bacteria, etc. Using suitable disinfectants. What are the disinfectants? Widely used disinfectants are chemicals like chlorine or ozone, and also it can be radiations like UV. This is considered as the final step in the treatment of drinking water. Here we can see a chlorinator which is used for chlorinating the water, where the raw water as well as liquid chlorine or concentrated chlorine solution is administered from the top of the chlorinator. And you can see baffle plates here which will enable adequate mixing of the chlorine and the water, which will lead to proper disinfection. And the sterilized water will be coming out through this outlet. Well, the efficiency of the process is enhanced by a slightly higher temperature. See, you can see here, it depends on the temperature and lower pH, and also time of contact. That is, towards the beginning, the chlorination is found to be more effective, and as time passes, the efficiency is found to decrease. But how does chlorine act as a disinfectant? Let's have a look at the chemistry behind chlorination. When chlorine is added to water, immediately a chemical called hypochlorous acid, HOCl, is formed. And this has the ability to deactivate the enzymes present in the microbes and thus killing them. This is how HOCl is formed. Chlorine plus water will form HOCl along with HCl. And the HOCl immediately kills the microorganisms. Now let's compare the disadvantages as well as advantages when chlorine is used as the disinfectant. Well, considering the advantages, it's highly effective, it's economical, easy to operate, and easily available, easy to store also because it's stable, no deterioration even on keeping, and it also ensures residual protection. What does that mean? Even after the chlorination process, a residual chlorine of the concentration, permitted concentration of about 0.1 to 0.2 ppm will remain in water, which will ensure that reinfection will not happen. So this is possible in chlorination. Whereas coming to disadvantages, we know that the chlorinated water can cause bad taste or bad odor, skin irritation, hair loss. These all happen when the residual chlorine is above the permitted level or dosage. And this may lead to the formation of THM, what are they? Trihalomethanes, which are carcinogenic. And in high dose, chlorine is found to be toxic to the biota, including fish. So this is a comparative study. Let's have a look at the chlorinating agents other than chlorine. Examples are bleaching powder and chloramines. Here also the principle is the same, the chemistry is the same. HOCl is formed which will kill the microorganisms. First let us have a look at the bleaching powder, that is CaOCl2. When it comes into contact with water, it first forms chlorine and then the chlorine when it comes into contact with water will form HOCl. And this HOCl will act on the microbes. Now coming to chloramine, it directly forms HOCl when it comes into contact with water as per the equation given here. Now, chloramine has few advantages also because it doesn't cause the distaste or odor to water, and also it does not produce THMs, that is trihalomethanes, which are carcinogenic, and also it is found to last for reasonably longer time. When we talk about chlorination, it's very important to talk about breakpoint chlorination because it tells us about the right amount of chlorine required for disinfection as well as for residual protection even after the disinfection process. A graphical study will help us in understanding breakpoint chlorination better. Well, this is the graphical representation of chlorination. Here you can see it's a plot between chlorine dose on the x-axis and chlorine residual on the y-axis. Both these are expressed in ppm or milligrams per liter. And in this plot, point C represents the breakpoint chlorination. Let's now try to understand the graph better by following the curve OA, AB, BC. Step 1, OA. We are adding chlorine to the water, but there is no resultant increase in the chlorine residual. That is because the chlorine that we are adding is consumed by the reducing agents, ammonia, organic matter, etc. present in the water for their oxidation. That is called the chlorine demand. And once it reaches point A, we can see there is a sudden increase in the combined residual. And when it reaches a sufficiently high point B, destruction of the combined residual happens, followed by disinfection. Well, it goes on till the minima. Breakpoint chlorination C is reached, point C, please note. And at this point, the advantage of breakpoint chlorination is that the water will not have any microorganisms, any ammonia is not there, no reducing agents, no organic compounds, and no odor, no color, no distaste, and no weeds will grow. And also, residual chlorine starts appearing here, which will ensure that no reinfection happens. And the permitted dosage is 0.1 to 0.2 ppm of chlorine. Well, sometimes the presence of residual chlorine may lead to overchlorination. In that case, dechlorination has to be done in order to make sure that the chlorine is in the limited dosage or permitted dosage. This can be achieved in 3 ways. One, by adding activated carbon to the water sample and later filtering it off. Second, by passing water through a molecular carbon bed. And third, by using chemicals like sulfur dioxide or sodium sulfite or sodium thiosulfate. You can see one reaction here. Sulfur dioxide when added to chlorine present in the water will react forming sulfuric acid and HCl in small quantities. So that's it. Well, we know that chlorination is not the only disinfection process. We can also use ozone as a disinfectant. Well, ozone is produced by passing electric discharge through dry and cold oxygen. And the ozone thus produces highly unstable and it undergoes a reaction producing nascent oxygen. And this nascent oxygen will directly attack the DNA of the microbes, killing them. There are lots of advantages of using this method, that is no harmful residue is formed as oxygen is the only byproduct. And also water will not have any distaste or color or odor. It's a very effective disinfectant and also it removes viruses, parasites like Giardia, Cryptosporidium, etc. And for this reason, it is also called a virucide. But there are also disadvantages. Mainly, it is a highly expensive process, not easy to store, and it's slightly corrosive in nature because of the production of oxygen, and no residual protection can be. Well, coming to the last disinfectant in the syllabus, that is UV. It's not a chemical, it's an electromagnetic radiation of wavelengths, the range 150 to 400 nanometers. This is usually produced using a mercury lamp, and it has got germicidal activities. Let us now consider the advantages as well as the disadvantages of this process. Well, coming to the advantages, there are many. No chemicals are used here. So no dangerous byproduct is here. And also for the same reason, no color, no distaste, or no odor to the water that is treated this way. It's an efficient method, and it destroys many microbes, including bacteria, viruses, algae, yeast, etc., etc. And as we all know, it's a household, a popular domestic device for water treatment, and it can also be used in swimming pools because no skin irritant or chemical is used here. But coming to disadvantage, the biggest disadvantage is that it is an expensive process. It requires technical expertise and also power supply. And for all these reasons, this cannot be used for municipal water treatment. And also, since light is used, turbidity may create a problem, and chances of reinfection is also there. Here we are coming to the end of the session. As usual, I am here with a few K2 questions. What is disinfection? Why chloramine is a better disinfectant than chlorine? Explain breakpoint chlorination and advantages and disadvantages of UV disinfection. Here, fourth question is an application level question. The question is asking for an ozone plant as a chlorination plant is there. What are the advantages and disadvantages? That is it. And the fifth one, again an application level question. Here, ion exchange, resin capsule, activated carbon and UV light are given. What are the functions? We know that ion exchange, removal of hardness, activated carbon, removal of organic matter and excess chlorine, etc. UV light for disinfection. Well, that's it. And please remember that in the ERP, I have uploaded the answer bank and the study materials. Go through that also. I have included the answers of all these questions cited here. So make sure that you're learning these properly, and we will be meeting soon with the next and the last video of this session. Till then, stay safe. Take care, all of you. See you soon.